Dr. Matina Thomaidou, VP, Head of Data Science at Dataseat and co-founder at Greek Women Do Tech. And before that, some history. Matina worked abroad at Facebook Ireland and IBM Ireland as lead data scientist. Her journey also involved Microsoft Norway, École Polytechnique in France, sorry about my French, and Accenture Greece, working on business insights and analytic projects. Her vision is to inspire younger women, we are in need of that are just entering the STEM world, and women who want to make a switch in their careers closer to the tech side. Matina's speech is about AI capabilities, ethics, limitations, and potential.
Thank you
Welcome,
so much
Matina.
for being here.
Thank you for having me.
The floor is yours.
Super. Hello, everyone. Shall we start? Cool. So my presentation today, you can consider it as a very short intro for the other very nice talks on AI from Yannis, from Eleftheria. We have some talks tomorrow as well on all of these latest hot topics, hot trends on AI and generative AI. So first of all, the interesting aspect here is the aspect of speed, meaning that, for example, ChatGPT took the world by storm, where it reached over 100 million users in just a matter of 2 months. You can see the chart that it reached 1 million user in about a couple of days. ChatGPT is indeed generative AI, brand new concept based on LLMs. In general, generative AI is based on the concept of generative adversarial networks, where we're talking about the creation of images, and transformers, when we're talking about LLMs and the creation of text. But AI and machine learning, these are not very new concepts. These are fundamental, let's say, kind of sectors and techniques that we have seen in the software engineering and tech world. But it's interesting to understand a couple of differences in order for you to understand with which different roles or personas or experts you should collaborate, depending the issue that you want to dive deeper into. Or, for example, how you should model a problem whenever you want, for example, to solve a certain project. So AI is a very big umbrella of different families of machine learning statistical techniques. When we use the phrase AI by itself, typically we mean tasks that they have to do more with the NLP world, with natural language processing, with text generation, with autonomous agents. This is why we have this kind of intelligent robots whenever we are talking about AI. But when we're talking about, let's say, numerical features that we need to use in our algorithms and produce kind of predictions based on very structured, let's say, kind of rules, then we're talking about the family of machine learning. So there are different sets of problems when you hear that someone is working on these fields. And then we have the neural network, which is this kind of concept with nodes, layers, mimicking the human brain, trying to activate different layers depending the environment and the circumstances. And based on the complexity and the number of layers, then we are talking about deep learning. And this is where the foundations and the fundamentals of the current generative AI began. And this is also something interesting to mention, that these are not exactly mutually exclusive. These are concepts interdependent with each other, but it's just, I think, useful to know that there are a couple of slight differences. And we said that this is not something brand new. Applicable AI and machine learning, they have their roots back into 50s and 60s. A very important decade was the decade of 80s, where the nice gentleman here, Yann LeCun, who is the chief AI scientist in Meta right now, together with his research lab, introduced the concept of artificial neural networks. Then we had some, let's say, time where we are going to talk later of a mini pause, and then we had on 2014, Ian Goodfellow introducing the generative adversarial networks. About, let's say, this decade, from 2010 till now, we saw the democratization, open courses, coming from Andrew Ng, who is the co-founder of Coursera, and democratized the access to the knowledge of AI and machine learning through his very, very, I think, popular course. And what that did that make this introduce the curriculum of universities to have in their own, let's say, curriculum, AI and machine learning courses as the norm. And we're talking about a little bit of pause. Till mid, let's say, millennia, we had an issue where we had advancements from an algorithmic perspective, from a software engineering perspective. But because we didn't have the right infrastructure or the right teams, for example, we need to leverage DevOps, or we need to leverage more and more teams that they have to do with hardware. We didn't have also this kind of democratization through cloud. There was a mini pause, and all of these really nice algorithms came into light with the good power of GPUs, and then with the infrastructure of cloud. And this is important to see that you might see with a very, very high-speed advancements from an algorithmic perspective, but if you don't have the right infrastructure in the back end, it's just not going to work. And then, of course, we have generative AI. I explained earlier, like whenever we hear the words, the phrases of generative adversarial networks, we're talking about the creation of images. Whenever we're talking about transformers and LLMs, we're talking about the creation of text. So you can do, of course, various things with generative AI. And the major initialization, let's say, of this system comes through the context. So someone should initially provide the right context to all of these systems through prompt engineering. And once you do that, you have your very big LLMs back there helping you understand what is going on in the data. They are trained on very, very big amount of texts based on the internet. So someone would say, the internet, right? A very diverse world. So out there you have all of your different, let's say, bits and pieces you need for generating the right text. Very easy to understand in context learning. It's very easy to infer in context because exactly you have all this diversity, which is not true. On the original paper of this kind of introduction to LLMs, we see that they act as stochastic parrots. And the second thing, we see that indeed they are trained on the internet, but the internet by itself, it's not very diverse. There are a couple of, let's say, factors that they play a role into the participation of users. And I'm not even going to mention here, for example, racism or misogyny or other people in positions of power, but I will mention the example of ableism. We have this kind of battle between neurotypical and neurodivergent people. So because neurotypical, by definition, they're going to be the norm. Because of their numbers, they're going to be more than the neurodivergent people. You have right from the beginning, the first bias. They are overrepresented out there. They are more confident on how they are going to expose their opinions, and they might produce a bigger, let's say, volume of text compared with neurodivergent peers. So you have already there an encoded bias, and of course, this may lead to stereotypes. You might experience depending the group you belong, a psychological, let's say, issue of microaggression, of stereotype threat. So we see the very first, let's say, family of problems, the bias and the toxicity. But there are already solutions underway. So there are many different systems right now which are trying to tackle this problem. So for example, I will mention Facebook's Metasec. I will mention the Hugging Faces transformers. I will mention here the example and the paradigm of Google's Perspective API, which is a free tool. And this helps with the democratization of usage of it. And how does it work? So it's a typical machine learning task. They have human assessors, or of course, in your community, you have the human assessors, and they evaluate a couple of paradigms of text if they are toxic or non-toxic. This is your training set. Then on the test set, it's about a very typical machine learning task if they're going to predict with a certain probability if something is toxic or not toxic. And then we have the power of communities. So here we have a feedback loop. It's an iterative process where the users, the community, gives back to the assessment of this text. So for example, you can customize the thresholds. For a certain context, you might think that it's okay, I will deliver it as a non-toxic, this, let's say, phrase. For another instance, toxic, or you might explain what is false positive or false negative and give back this information to the system. And for example, I want to mention here that OpenAI used the original 3.5 model, and on the recent, March, let's say, 2023, I'm just laughing with the term of recent, with this kind of changes, but they introduce 4. Why? Because they managed to get understanding better in a higher accuracy user intention, but at the same time lowering the problems with toxicity and bias. What else do they do in the ChatGPT? You will see that recently they have added a paragraph at the end where they mention that this answer might be a mistake, and you should be, let's say, like a disclaimer, like a mini disclaimer, extra cautious of this answer. What do they try to mitigate? The other ethical, let's say, and problematic aspect of AI, which is that these systems sometimes hallucinate, and they produce nonsensical content. So they might generate text or image that doesn't make literally any sense. It could be very, again, problematic given the context, and of course, it will produce something that it's very, very fake compared with the truth that they need to represent. So again, this is a problem, but the solution is underway. There are different systems. They try to tackle this issue, and I will give the example of NVIDIA, the NeMo guardrails paradigm, where what they have done, here you will see a script which a language called Golang, resembles a bit the Pythonic syntax. And they try to introduce some conversational flows. They put there a couple of rails, where when the user asks a certain question, they might say to the bot that you can proceed by giving the answer, but depending the topic, for example, if it is a topic of politics or the stock market or health matters, you have to respond something along the line of, I cannot inform you, I cannot respond, or I might give you something that it could be a mistake. So as we prepare for the future, recent weeks, I'm sure you have seen already in the news, Biden, US government. From the European side, we had the AI Safety Summit. They're trying to collaborate, politicians, and they try to discuss about all the challenges, not only in terms of ethics, but in terms also of cost, how they should regulate this kind of systems. In the recent news also, it was Elon Musk who said to Rishi Sunak in the AI Safety Summit that we might have a problem with the future workforce, a typical, let's say, issue that someone mentions around these areas. But the truth is that all of these matters, they need collaboration they need synergies across different kinds of groups, personas, roles. For example, software engineers, scientists, philosophers, policymakers, to ensure that we have think about all the different possibilities and all of the different aspects of the challenges. So in trying to develop a responsible, at least kind of AI system. So we have seen the problems, we see also that there are solutions, and we should work with a solution-driven mindset towards those. Thank you very much. I'd like also to mention that if you would like to discuss on these matters, but also about the Greek Women Do Tech, feel free to drop at our 4:30 mentoring sessions. Thank you so much.